Let's talk about server-side data loading. A common strategy is to use get server-side props as popularized by Next.js. In this approach, get server-side props is async and can run on a server to fetch the required data. The data is then passed to the root component through props. It is very simple to understand and see what's going on. The disadvantage, though, is that there is no automatic type flow information. You can see that you manually have to put in the name of the function. This is because a client-side code cannot directly access the value of the function. It can only refer to it through a type. But I think the bigger problem with this particular approach is the fact that it's not composable. Imagine you have a child component in here that you wanted to add. The child component would have its own data that needs to be loaded. And you as a developer have to make sure that the data is somehow included in the get server props and then passed over to the child. This is what React Server Component is trying to solve, which we'll discuss later. A similar approach to the problem is to use a loader, which was popularized by Remix. The loader works the same way as get server props, but there's a difference in that instead of getting hold of the data inside of the props, you get a hold of it by calling useLoaderData method. Just as before, the type information does not automatically flow, and just as before, the composability is tricky because if you have a child component that needs the data, there can only be a single loader that can fetch all of the data necessary. Let's look at how React Server Components solve this problem. Instead of having a separate loader method, the data loading code is directly invoked from the component. That means this component can no longer render on the client and hence the name React Server Components. The advantage of this approach is that now the type information flows automatically to artists, as in this particular case. The other advantage is that each component can load its own data. This playlist component is a child of the page component, and you can see that its own separate data loading scheme inside of it. This solves the composability issue. However, the composability comes at the price. And in this particular case, what we have created is a waterfall. Until the getArtist is executed, we cannot execute getArtist playlist. And this waterfall is the trade-off that we have for composability. There is another way to solve this problem. Let's go back to the loaders, but instead of having a single loader, let's have a loader per component. So in this particular case, the default component requires the top friends, and the top friends is a loader that runs on a server, and we get a hold of the use method. The first thing you're going to notice is that the type information flows automatically. This knows that it's a string array because we directly refer to the loader method. The second advantage of this is that we can now have multiple loader methods. So let's assume we have a third-party component that we are importing from somewhere else and we would like to use it. The third-party component also has a loader method for itself, and internally it refers to its data directly. So we now have composability in the sense that we can compose different components inside of our application, and each component has its own data loading. However, there is a bit of a cost to pay, and that is that we need to tell the router about the data loading component. And so not only do we have to import the friends list, we also have to tell the routing system that, hey, this particular component we're using has its own data loading that needs to be done. Let's compare all of these approaches. The loading of the data is placed in a separate method. Because it's a separate method, we don't get automatic type flow and it's not really composable. However, what we do get is request hoisting, meaning that the framework can start fetching the data eagerly as soon as it knows which particular route is activated, and the data will become available to the component once the rendering starts. The loader approach is essentially the same thing as a get server static props, with the advantage that you no longer have to do prop drilling. Instead, the component can directly access the data through use methods. But in terms of composability and a type flow, it is really the same thing. Now, React Server Components tries to solve the composability problem, as you can see over here, and it is indeed composable, and it does solve the type information flow problem. The components are now correctly typed. However, this benefit comes at the expense of the waterfall. It is possible to create a waterfall inside of React Server Components, and React Server Components can no longer do request hoisting. It is possible to work around this particular problem, but it is not something that's available out of the box. The multiple loader approach basically takes the benefits of get server-side props in the sense that it has a request hosting, it doesn't suffer from waterfalls, but it has the benefit, it's composable, and it has the type flow information correctly flowing through it. Now, there is a cost to composability, while as in the React Server Components, the composability is just out of the box. In the case of multiple loaders, there is a little bit of work where you have to re-export the data fetching for the route information.